In this module, we will discuss about the path determination, how the router will determine the best path, how it will select the best path, we will see. Okay, and packet forwarding mechanism, I will explain how the router forward the packet to the destination. And the basic router configuration, I will also explain to you how you can configure the basic router configuration. Okay, so and IP routing table, if you will see here, describe the structure of the routing table and static and dynamic routing. Compare the static and dynamic routing concept. So all these things I will explain in this chapter, inshallah, today, and you will see how the things path determination. Okay, so see here. So router has two functions, as I explained before. So router has two functions. So when the router receives the IP packet on one interface, it determines which interface to use to forward the packet to the destination. This is known as the routing. So in the routing, see here, this is the routing. So mean the router receives the packet on one interface and it determines which interface used to be forward. So it will check. So is it a gigabit 00 interface, serial 01 interface, or which interface need to be forward? So this is called the routing. Okay, so this is called the routing. So which interface need to be forward? Just wait a while, just 1 minute. The packet which received by the router, maybe that packet will directly go to the final destination. And or the second scenario. Now the first and the second scenario I will explain you in this here. Okay, suppose we have the router here. So the router, so this is our router, and so here we have the PC. This PC is connected with the final destination. In between you have a just let me take. So this PC is connected with the router, directly connected with the router here, and then so the final destination is also with the router. See the first scenario here. So first scenario, try to understand the interface that the router used to forward the packet may be the final destination. So this is the one. This is the one. Just let me take, and I will the interface is the final destination. It can be a final destination. If this is the case, if you will see this is the case, just let me see here. So now the router, as I told you, the interface that the router used to forward the packet. So it can be a final destination. In this case, what it will do? So it has a multiple interfaces. As I told you, the router connect with the multiple. It can be connect with the multiple network, which means that it has a multiple interfaces that each belong to a different network. Maybe one more network is connected here. We will see if we do, if we have, no, we have, see here, we have only two interfaces here. So one network is connected with this interface, another network is connected with this interface. So when the router receives the IP packet on one interface, see on this interface, okay, all of you, is it visible for all of you? Yes, please. See here. Now, when the router receives the IP packet on one interface here, so what it will do, it determines which interface to use to forward the packet to the destination. So maybe it has a multiple interfaces here. So in this case, we have only one interface, and in this interface, it will forward to this interface. Okay, so then this process is called the routing. This process is called the routing again. So what is the routing? Again, try to understand when a router receive the IP packet on this interface. Suppose if this PC sent a packet from this source to this destination, and destination is directly connected, as I told you, so it is directly connected. So mean the final destination is directly connected with this router. Okay, so once it will receive the packet on this interface, what it will do, what the router will do, router will just let me, so this is your router. So the router, what the router will do, router will determine which interface to use to forward the packet. So if this is the destination here, so it will forward the packet to this destination because this is our destination. So it will check, it will determine, and then it will forward to the final destination. So this is the first scenario. So the second scenario, you can see here, the interface that the router used to forward the packet may be the final destination, and this is our final destination, or it may be the network connected to another network. So it means, so if this is the case, just 1 minute, if this is the case, the second, this is a second scenario, if you, sorry, here, so now I will show you the second scenario here. So we have another router and we can connect. Just in between we have a gigabit, and this is our second scenario now. In the second scenario, if you will see here, so in the second scenario, it may be a network connected to another router that is used to reach the destination network. So these are the two different scenarios. The first scenario, the destination is directly connected with the router. Now the destination is not directly connected with the same router. So what it will do, it will forward the packet to the second router, and the second router will forward this packet to the final destination. Okay, so each network that a router connect to typically require a separate interface, but this may not always be the same case. Okay, so the primary function of the router is, what is the primary function? The primary function of the routers are to determine the best path. So what is the primary function of the router? So the primary function of the router is to determine the best path to forward the packet based on the information in its routing table and forward the packet toward the destination. So this is the basic purpose of router. So router is nothing, it is just like a computer. See, same like the computer, it has the CPU, it has the processing unit, CPU, it has the RAM, it has the NVRAM, it has the flash. Flash is the permanent memory. Please try to understand. It is nothing, it is just like a computer. So you can make your computer as a router as well, because just you need to install the iOS, okay, and the routing table and all those things, you can do it. So if the time permit, I will explain to you how you can make your computer as a router. So it is just like a computer because you need to install the iOS. So this iOS, here you have the separate operating system for the router, because the router contain the routing table, fib table, okay, so adjacency table. These tables are stored in the routing table, okay. So that is why, so router is nothing, it is just like a computer, okay. So don't get confused, the router is a very special device, but the basic purpose of the router is to determine the best path, to select the best path to forward the packet. So based on the information in the routing table, it will forward to the destination. So these are the two scenario, okay. Now come to this one. So this is the primary function of the router, and now router functions example. Now I will show you one simulation, then you will understand by yourself. So here I have the simulation. Just let me bring the simulation here. There is a simulation. Okay, this is a simulation. Okay. See here. Now please try to see this one here. So how the router forward the packet. Now you can see the first scenario. First scenario is here. This is the second scenario, not the first scenario. So router will receive the packet, and just see the simulation what I explained to you. Okay, so just try to understand this and see the packet is coming to the router 1, and router 1 will check the routing table and to map to discover the best path for the given network. You can see here it is not directly connected. It has the static route 3.0 network, and then it will forward this one to this interface. Now then what it will do, see here, now it will follow the same process. Now this network is directly connected network, and then it will forward to the final destination. Now what we understood from here, so we have directly connected network, and now we have remote network. Now just try to understand these two concepts. So what is directly connected network and what are the remote network? 1 minute. Let me open the Paint. I will explain to you. So what is a directly connected network and share control. Okay. Sorry, what is this? What is happening now? Okay, snipping tool. Let me take the snipping tool, and here we can use. Okay, so this is the one. So I have this network. Okay, now see. So what is a directly connected network and what is the remote network? And can anyone tell me what is a directly connected network in this case? Yes, please. So what are the directly connected network? Yes, Azza. What are the directly connected network with respect to router 1? With respect to this router 1, suppose this is our router 1. So this is router 1. With respect to the router 1, what are the directly connected? So see, this is my router 1. So what are the directly connected network in this case? Directly connected network, yes.
192.168.1.0.
Yeah, so this is your directly connected. It means this network is directly connected, and this network is also directly connected. So this one is also directly connected. If you see here, so this network is also directly connected. Okay, so in this case, we have two directly connected network. Okay, so we have two directly connected network. So what are those two directly connected? Sorry. So these are the two directly connected network. So directly connected network. Okay, with respect to router 1. Okay, so I will write it here, router 1. So router 1 directly connected network. So what are those? 192.168.1.0. So this is the directly connected network, and 192.168.2.0. So these are the /24. Okay, so don't forget to write this prefix notation. This is very important. So these are the two directly connected networks with respect to router 1. Now, if I will ask you, so what are the directly connected network for router 2? Can you tell me, please? Yes. What are the directly connected network in router 2? Yes. Yes, please.
3.0.
192.
Yeah, 3.0. Good. 192.168.3.0. So let me write it here. So this is 3.0. So what is the other one? Yes, any one of you? What is the another directly connected?
2.0.
2.0. So 2.0. So these are the two directly connected network with respect to router 1 and router 2. Now, if I ask you, where is the, just 1 minute. If I ask you, so what are the remote network with respect to router 1? First, router 1 remote network. Okay, remote network WRQ. Okay, remote network. So with respect to router 1, okay, what is the remote network? What is the remote network?
3.0.
So 3.0. So this is our remote network. If you will see here, so this is our remote network with respect to router 1. Okay, so we will simply type 192.168.3.0. So this is our remote network. So this is the remote network. Okay, and now with respect to router 2, so what is the remote network? Anyone can tell me now? Yes.
Not directly connected with router.
No, I'm asking the remote network. What is the remote network with respect to router 2? What is the remote network? Remote network
1.0.
1.0. So this is the remote network. See here. So these are the this is the remote network, and these are the directly connected network with respect to each router. Okay, so this concept should be clear enough. Okay, now let's go to the best path longest match. Now, best path longest match mean the best path in the routing table is known as the longest match. Okay, be quick. So the longest match is your prefix. It consists of the prefix. So if you will see here, the routing table contain a routing entries consist of prefix notation. If you will see here, and here I think it is not much visible, but let me check. So I will just show you somewhere here. Yeah, no, I think this one. No, somewhere here. Yeah, if you will see here, so this is the prefix, see, longest match. So try to understand here what it is saying. So best path routing table contain the routing entry consists of prefix, network address, and the prefix length. See here, so this is the prefix length, /24 is the prefix length. So it contain in your routing table. If you write show IP route, okay, so it will show you the routing table of the routers. Okay, it will show you the routing table of the router, and it will show you how many directly connected networks are there, how many static routings are there, and how many just let me increase the font size here. I will just explain you some of the concept. See here. Now, if you will see here, so this S stand for what? S stand for static routing. If you configure the static routing, it means it will show with this symbol S. S symbol stand for static routing. Okay. C stand for the directly connected network. Okay. So this is a directly connected. We are in the router 2. In router 2, so this is our directly connected network 2.0 and 3.0. So this is 2.0 and 3.0 is directly connected, as we know. Okay. If you want to see the routing table, it will elaborate everything. So these are the two directly connected network, 2.0 and 3.0, and this is the static routing. Static routing means this is your destination network. If you need to reach to this destination, see in the routing table, the entries are very much clear. If you want to reach this destination, this is your destination 1.0. So this is your 1.0. See here, if you want to reach to this network, it will go via this interface IP address. So this interface IP address is 2.1. Okay, so through this interface. So in a couple of minutes, I will explain the static routing in detail. Okay, just try to understand. So this is the static routing. If you will see here, S stand for static, I stand for IGRP, R stand for the RIP. These are the routing protocols. Okay, RIP is the routing protocol, M is the mobile, B stand for BGP. Okay, border gateway protocol. It is only used for the ISP. Okay, and D stand for the EIGRP. Cisco proprietary protocol EIGRP. EX stand for the exterior EIGRP. If the symbol is O, it means the OSPF, you are using the OSPF. So these are the different symbols you can see, and you can easily understand, okay, this symbol, it means you are using static routing. It means you are using dynamic routing, EIGRP. If that symbol is D, it means you are using EIGRP. If it is R, if the symbol is R instead of S, it means you are using a RIP. Okay. Now, best path longest match. Best path longest match, it means if we will come to this slides, here is a slide, just let me go to the slide. See here, the best path in the routing table is known as the longest match. So how the router will select the best path, it has the criteria as I explained you before. So it will select based on the prefix notation, it will select based on the administrative distance, and it will also select the best path based on the matrix. Okay, but we try to focus here the best path longest match. Okay, if your destination network are the same mean from the same network with different subnets, then it will use the best path longest match criteria to select the best path. Okay, to select the best path, it will use the longest match. So now if you'll see, routing table contain the routing entry consists of prefix, mean the network address, prefix are the network address. Okay, and the prefix length. So prefix length is, as I explained you before, the prefix length is your network address. Okay, so how it can be this one here, if you will see here. So in this case, so 24 is a prefix. See, 24 is a prefix. What it, see here, this 24 is denoting which portion, network portion or the host portion? Yes, this 24, can you tell me this 24 is exhibiting the host portion or the network portion? Yes, please. Any one of you, please, can you tell me?
Network.
Network. It means 24 bits for the network and 8 bit for the host. So it means, so total you have 32 bits in IPv4. Okay, in IPv4 you have how many bits? You have total 32 bits. Okay, in IPv4. Just try to understand IPv4 32 bits. Okay, 32 bit address. But in IPv6, if you, I will explain you, I think later on. So you should know in IPv6 128 bit address. Okay, this is hexadecimal notation, but we have 128 bits. Okay, hexa notation. Okay, so but here total we have 32 bits. Out of 32 bit, 24 bit for the network and 8 bits for the host. Okay, if I will write it here 26, it means 26 bits for the network and 6 bit for the host. Okay, so try to understand this concept. Okay, so now for there to be a match between the destination IP address of the packet and the route in the routing table, a minimum number of far left bit must match between the IP address of the packet and the route in the routing table. So the prefix length of the route in the routing table is used to determine the minimum number of far left bit that must match. So longest match is the route in the routing table that has the greatest number of far left matching bit with the destination IP address of the packet. So the longest match is always be the preferable route. So longest match will be the preferable route. Okay, so longest match is always be the preferable route. So now see here, this example here, if you will see, this is our destination network. So in the routing table, it contains 3 entries with the same network, we can say. So the router has 3 route entry in its IPv4 routing table. So in the routing table that match the packet with 1 0.10. Okay, so first it will match with this 12, then it will match with 18, then it will match with 26 of 3 roots. Okay, so which one will be selected? This one will be selected because of, just let me change the color here. So this will be selected, /26 will be selected because it has a longest match, and would be chosen to forward the packet. See here why it will be selected here. If you will see here 0.10, so this is a binary notation. This is a binary notation of this decimal number IP address. Okay, this is a destination. So if you will see here, same network 0.0, 0.0 and 0.0. If you will see here, but here the most far left matching bits are, if you will see 1.0, 0, 1, 0, and up till this point, just let me change the color. See now, up till this point, if you will see here, we have the same matching bit. But if you convert 170 to 16.0, it means the 12 bits. So it means the 12 bits are same. 12 bits are same. So 8 bit, 9, 10, 11, and 12. So these 12 bits are same. So these 12 bit, if you will see here, just I will use this one, this color. Okay. So here 12 bits are same. But here you can see 18 bits are same. 18 bits. So 8 and 8. 16, 17, and 18 up to this point. Just let me take some other color. And here I will use, okay, this color. Okay, see here. So 18 bits are same. But in the longest match, how many bits are same? The longest bit. So you have more number of bits. It means 26 bit. 8 plus 8. See, now let me also choose the color. So these are the 8 bit. Sorry, up to this point. 1 minute. And here I will choose this color now. Okay, this color. Okay, now see here how many longest bit matches. Here 8 bit, 8 bit, 16 bit, and 8 bit, 24 bit, 24, 25, and 26. It means more number of bits are matching here. More number of bits are matching here. So it means this route will be selected. This will be the best route to forward to this destination. Okay, so try to understand the longest match will be the best route. So longest match is always be the preferable route, mean the best route. Okay. Now come to the IPv6. As I told you, so it is also the same. So IPv6 packet has a destination IP address. This is the destination IP address. If you will see, so 3 routing entries. You will see here 1, 2, and 3. So this router contains 3 routing entries. Okay, but only 2 of them are the valid match, and this one is not the valid because this is a different network. Okay, it does not match because here we have the same network, this one, and this one is the same network. Okay, but which one will be the preferable route? Which one will be the preferable route? The longest match will be the preferable route. Okay, because here we more number of matching bits. Okay, more number of matching bits, longest prefix matching bits. Okay. Now I already explained you the directly connected network and the remote network. Okay, I will not explain you again. Just try to understand. So in remote network, we have 2 type of networks. So let me explain directly connected, then we can come to the remote network. Directly connected networks added to the routing table when the local interface is configured. When you will configure this interface, so it will see here, once you will configure this interface, it will directly come to the routing table. When you will configure gigabit 0 interface, mean you will assign the IP address, directly it will come to the routing in the just I will give you the example here. Suppose here you have this this IP address 192.168.1.0. Suppose this is the network on this side, and here you have this network 2.0. Suppose we can say 2.0. Okay, so both are /24. Okay, once you will configure these 2 interfaces, gigabit 00 and gigabit 01 interface. Let me configure and you will see. So here I will go to the gigabit 00 and let me assign the IP address gigabit 0.1.1, sorry, 1.1, and subnet mask same. Okay, and gigabit 01, so it will be 2.1. Just be quick. So 2.1, and this is the IP address. Okay, so now if you will see here, if you will write, I will just simply type show IP route. See here, show IP route. Now see here, so one dot, so this is the network, directly connected network. So this is the interface IP. 1.1 is the interface IP. So I assign this IP address to this interface gigabit 00 interface. Okay, so this is a network. It means directly connected network. Once you will configure, it directly come to the routing table. It directly come to the routing table. Okay, now let me also here, I think I forget to 2.1. Okay, it's because this one side and the other side we also need to make it on. Then this is 2.1 gigabit 00. So here 2.2 dot 2. Okay, now see here. So these are the, this is also directly connected network too. So it will come, these two network, it will come into the routing table. Just show IP, show IP route. Okay, show IP route. If you will see here, so these two directly connected network. See, so this is the network, directly connected network through this interface. But what is the IP address of this interface gigabit 00? So this is the IP address of the interface, and this is the prefix notation. So we can say slash 32 is the best one, but here we are using 1.1, and here is 2.0 is the network. See, so these are the two directly connected 1.0 and 2.0. So these are the two directly connected network. Okay, so once you will configure, so it will directly come into the routing table. Okay, so this is the first point I just want to elaborate here. So when the local interface is configured with the IP address and subnet mask, mean the prefix, and it become active and up, it will come to the routing table. It will add it into the routing table. Now the remote network. So what are the remote network? The network that are not directly connected to the router. Learn about the remote network in two ways: static routing and dynamic routing. See here. Now in this case, let me also show you how you can configure the. So this is 192.168.3. Suppose 0/24. Okay, sorry. So this is the, this is another network. Now if I need to configure the network here, the static routing, okay, the remote network with respect to router 0. Okay, so what is our, suppose here what I need to configure here, router 1. Okay, in router 1, if I need to configure the network, okay, the remote network by using a static routing. Okay, so if I need to configure a remote network on router 1 by using remote network by using static routing. Okay, so what will be the what will be the command here if I need to configure a remote network by using a static routing? So what will be the command here? Yes, please, can you tell me? Yes, any one of you? Yes, any one of you, please, can you tell me how I can configure the static routing? Can you tell me, please? Any one of you? Yes. See here. Now, see. So if you need to configure the static routing, okay, if you need to configure the static routing on router 1, so suppose, sorry, not router 1, this is router 0. Okay, this is router 0. Okay, you need to configure the remote network, okay, on router 1. So what will be the command? So here you can just type IP root, IP root. This is the command, IP root. Okay, now what is your destination network with regard to router 0? What is the destination network? This is a destination network now. If you will see here, so this is a destination network. Just let me take some other color. I will just, so this is a destination network. Yeah, so this is a destination network with regard to router 0. Okay, sorry, let me write it here. So IP root, so destination network is 192.168.3.0. Okay, so this is our destination network. Now I need to tell my router if any packet belong to this network and it has this subnet mask 255.255.255.0, then forward through this interface gigabit 01 interface. So I will write. Okay, so this concept I will explain you later on. We have directly connected network, and because we need to mention the interface IP address and how we can configure the like mean we have a different way to configure the static routing. Okay, so we have a different way to configure the static routing. The first one you can configure by using a static route by using directly connected network, or you can configure by using the interface. Just you can mention the interface. Okay, I will explain you in the chapter number 15 in detail. Okay, so now here the gigabit. So if this is a destination and this is the subnet mask, so what is the exiting interface with regard to router 0? What is the exiting interface? Gigabit 01. If packet belong to this network and this is the subnet mask, so this is the exiting interface. So here we will mention gigabit 0/1. Okay, so we need to write this command on the router 1. Okay, so simply we will write configure terminal and simply type IP root gigabit 01. Okay, now you can see I have configured the static routing. Before there is no S. There is no S. Okay, now router 1 finished. Now we need to go to the router 2. In router 2, see now this is router 0. Now we will go to the, sorry, this is router 1. Now router 1 with regard to router 1. Okay, so what is the command? Same IP root. Okay, subnet mask. Yes, please. So what is the destination here? With regard to router 1, if I need to configure the remote network by using static routing, so what is the destination network? With regard to router 1, so this is the router 1. Yes, please. Can you tell me? Yes. Be quick, please. Tell me. I'm just waiting. With regard to router 1, so what is the destination network? Yes. Ammar Khamis. Ammar. Ammar Khamis. Ammar. Ammar Khamis. Can you hear me? Ammar Khamis. Hello. Ammar. Ammar Khamis. Abdullah Umar, where is Ammar Khamis? Wallah, he's not. See, but why he's not giving me the answer? Even if he don't know it means so he's not listening the lecture. Ammar, so please, you should be a responsible student. And if you don't, no problem. You are the student. I can understand, but at least you can reply me. If you will not reply, I will understand. Now you are not listening the lecture. You just connected with the MS team, and then you are doing something else, not listening a lecture, not attending a lecture. Please, this is not acceptable. This is for you because we are putting this effort only to you people to explain all those concepts, not simply come online and just deliver the lecture. Please try to be responsible student. Now you have only 2 weeks left. Third week will be the assessment week. So in 2 weeks, we need to finish everything. Please, this is my humble request to all the students. Please reply at least, even if you don't know the answer. Okay, I will explain you. Yes, Abdullah Umar. So what is the, with regard to router 1? So what is the destination network with regard to this router 1? So what is the destination network? 3.0. No, with regard to this router 1 here, no? What is the destination? See, for router 0, sorry, 1.0, yes, it will be 1.0. 3.0 is a destination for router 0, for this router 0. So this is a destination. For router 1, so this is a destination, okay? Just you can see here, let me take some other color. So suppose this is, so this is a destination. With regard to router 1, so this is a destination, okay? So this is a destination network. So here we need to change 1.0 on router 1. So this is 1.0 and this is a subnet mask and exiting interface. So what is the exiting interface here? What is the exiting interface? Gigabit 00, yeah? Gigabit 0/0. So this is the exiting interface. Now, if you will configure this one, just let me go to the router here and let me, so here close. So here gigabit 01, let me sign the IP address first. Sorry, control Z. So 192.168.3.1 subnet mask and this one. Okay, done. Here we'll go to the CLI and now we will write here the IP address. Okay, exit. Oh, so here we need to configure the static routing on router 1. Okay, so this is the, see here, IP root destination network 1.0 is the destination network, subnet mask and this is the exiting interface. Gigabit 00 is the exiting interface. Now, did you observe? So these things are added in the routing table. So now if you will see here, now you will see, so before it is only directly connected network. Now we have configured the static routing. So you will see the routing table now, show IP route. Now, did you observe here? We have configured the static routing on router. This router, did you observe now? Now we have this static routing we have configured and it is connected through this interface. Now, if you go to the router one also you can see show IP route. Now you will see here. So it is not added IP route. Okay. So here gigabit 3 dot 1 minute. Did I gigabit 01 3.1 255 255.0 here 2.2. Just let me check. Gigabit 00. Okay, IP route. Okay. Now if we will see here, show IP route. Why it is not showing now? Show IP route. Show IP. Sorry, show IP route. Okay. See here now static routing 1.0. This is the destination network. It is configured on the this 1.0. This is the destination. See here the S. So now we know that. So how to configure the static routing, the remote network. Now if you will ping from here to here, you can easily ping. You can easily connect. Once it will, the packet will come to this router. It will check what is the exiting interface. It will check in the routing table. Yes, this is the network. This network is not connected with me, so it is connected with the other remote network. So then it will forward to another network, and another network, once it will check its routing table, then it will forward to the destination. So this is the basic way to forward the packet. Okay, so this is the way to build the routing table. And so we have directly connected network and the remote network. So we have static routing and the dynamic routing. Dynamic routing is not the part of this curriculum. So the dynamic routing, just for your understanding, so it is adding to the routing table when the routing protocol dynamically learn about the remote network. Okay, so we will not do any practical regarding dynamic routing. Just dynamic routing, we can use RIP, OSPF, EIGRP. These routing protocol we can configure on the router. So it will add those network automatically. They will share their routing table with each other. Router 1, if we configure here the dynamic routing on router 0 and router 1. So we just need to configure these network and they will share this information with each other and update the routing table. Okay, just for your understanding purpose. Now default route. So default route, let me check, do we have any simulation here regarding the, yes, remote network and default route. Now default route, so default route specify the next hop router to use when the routing table does not contain the specific route that match the destination IP address. If there is no destination network, if this is the scenario here, if we will take this scenario, let me control Z. If we have 1 minute. See here, now suppose if we have, this is a router and this router further connected, sorry, why it is showing like this. Okay, now this network is further connected with the, okay, let me take this one here, the example. Okay, so further it is connected with the, not the destination, just 1 minute, I will take it in this way. And let me use some router here. If we will use any other router, or suppose if we will take, okay, suppose this is our cloud. Okay, so if it is connected with the net, okay, this is our internet, this is, we will say internet. Okay, internet. Suppose, okay, if we are connected with the internet and we don't have the default static route, if suppose we did not configure the default static route, what will happen? It means default static route, where it will be used, how it will be used, and when it will be used. Now I will explain you. First, try to understand. It will specify the next hop router. If you did not configure any network on your router, then you can configure the default route. Okay, so how you can configure the default route? Simply, instead of this one, you can configure here, just type IP route. just type IP root, then type here 0.0.0.0 and subnet mask is 0.0.0.0 and exiting interface we can say. You can say the exiting interface is gigabit. If it is router 1, so the exiting interface will be gigabit 0/0. Okay, so this is the default route. If you did not configure this one, you can also configure the IP default route, but it has a disadvantage. Now, let me discuss first what is the disadvantage of having, just 1 minute. Okay, so having a next hop router instead of static routing. So it will default route specify the next hop router to use when the routing table does not contain the specific route that match the destination IP address. This is the first thing. If your destination IP is not matching, then what will happen? It will use the default route. It will use the default route. At least it will forward. It mean to say if this PC, okay, if this PC is going, just let me copy, control, snipping tool. I will use a snipping tool. Suppose if this PC is just 1 minute. So here, now this is your internet. Okay. Suppose this PC, if it is it is sending a packet to a Google, GWG Google. Okay. Google.com. Okay. Definitely this network will not be present in the routing table. Okay. Not here and not in this router. Then what it will do? It has a two scenario. The first scenario is it can discard the packet. It will discard the packet. Okay, this is your dustbin. It will discard the packet. Mean it will delete the packet. If you did not configure the default route. Okay, if you did not configure the default route, what will happen? It will delete the packet. It will discard the packet. Okay. And if you configure the default route, okay, you are telling if any network that does not contain in the routing table of this router, okay, of this router, then simply forward to the ISP. Simply forward to the ISP router. So we are telling, so through this interface, you can forward this packet to the ISP. Now it is the responsibility of the ISP to look into this matter, this address, and find the destination. Okay, so this is the basic purpose of default route. Okay, now see the default route can be entered manually or as a static route, as I explained you. So you can configure as a static route in this way. Okay, so you can configure as a static route in this way, or it can learn automatically from the routing table. Okay, so a default route has a 0 prefix length. See, so this is 0 prefix length. This is a 0 prefix length. So it means no bit need to be matched to the destination IP address. Okay, so it means that no bit need to be matched to the destination IP address for this route entry to be used. If there is no route with the matching longer than 0 bit, the default route is used to forward the packet. If no bit is matching, if no destination IP address is matching, then this route, then default route is used to forward the packet. Okay, so then this default route is used to forward the packet if no network is matching, if no network is available on the router. Okay, it's clear, all of you? Yes, please. Clear? So then the default route is used to forward the packet. Okay, so then this is the default route. Okay, so default route is sometimes referred as the gateway of the last resort. This is a gateway of the last resort. I mean, it will check each and everything. It will also slow up the process, but it is really helpful. Okay, it is really helpful. Now packet forwarding mechanism. So this packet forwarding mechanism, first of all, you should understand how your router will interpret the packet, how it will interpret the data link frame with encapsulated IP packet arrive on the interface. Okay, so suppose this is the router. Okay, suppose this is our router. Once it will come to the router, okay, it will check the destination IP address. Okay, so this is the destination. Suppose what is the destination IP address? It will check. So once it will examine the destination IP address in the packet header and it will consult the routing table. It will check the routing table here. Just let me increase. Okay, it will check the routing table. So the router find the longest match prefix in the routing table and the router encapsulate the packet in a data link frame and the forward it to the egress interface. Mean it will forward to the, maybe it can be a destination. It can forward the packet directly to the destination device, or it can forward to the next hop router, as I explained you scenario 1 and the scenario 2. So maybe your final destination is directly connected with the router, or maybe your final destination is the next hop router. It may be a next hop. Okay, by this way it is forwarding the packet. Suppose in some cases, if there is no default route, then what will happen? If it will check the IP, okay, it will check the routing table. If it will not find the destination network, then what will happen? Yes, please. If it will not find the destination network, then what will happen? It will discard the packet. It will send this one into the trash. Okay, it will send into a trash. Okay, see here. So if you will see now, it will send this one into a trash. Okay, so where it is, pen. So it will send into a trash. Okay, so this is a trash. It is going to send to the trash. Okay, so you should understand. Again, I'm going to tell you so if it will check the routing table, so this is the destination address. So in the routing, in the packet, it will check the destination IP address. Okay, if the destination IP address is matching, then it will forward this packet to the directly forward packet directly to the destination device. Or maybe that it is not a destination device, maybe it is a, just let me take the pen and okay, the pen. Okay, so if this is not a destination network and maybe it is a next hop router, then what it will do, it will again, then what it will do, it will forward this packet to the next hop router. Suppose we don't have the default route. If we did not configure the default route on this router, suppose this is our router. Okay, so this is our router. In the routing table, we did not configure the default route. So this is a default route. Okay, we did not configure the default route, and it does not contain the destination address. Okay, it does not contain the routing entry here for this destination address. Okay, then what will happen? It will check the routing table. If no network is available, no network route entry is in the routing table, then what it will do? It will discard the packet. It will send into the trash dustbin. Okay, it will trash because it will discard this packet. Okay, so this is a simple scenario. This is a very simple scenario. Now forward packet, next hop router, we already discussed packet forwarding mechanism. Now see here. So router support 3 packet forwarding mechanism. Now try to understand this one. So the router support how many packet forwarding mechanism? 3 packet forwarding mechanism. The first one is the process switching, fast switching, and Cisco Express forwarding. So it support these 3 packet forwarding mechanism. Okay. Now if you will see here, now we will discuss one by one which one is the most appropriate and which one is the more efficient way for the router to perform the task and to forward the in order to process the packet. Okay, now if you will see here, the first one is the process switching. As I explained you, for packet forwarding mechanism, how many packet forwarding mechanism we have? 3 packet forwarding mechanism. The first one, process switching, fast switching, and Cisco Express forwarding. These are the 3 packet forwarding mechanism used by the router. Okay, the first one is process switching. The first one is the process switching. In the process switching, this is the old packet forwarding mechanism still available for the Cisco router, but it is the older packet mechanism, process switching. So when the packet arrives on the interface, so this is your interface. Okay, this is the router. This is the router. Okay, suppose this is the router. Okay, this is a router. Okay, so this is your router. Once the packet, so this is your packet. Okay, so this is the packet, the first packet. Okay, if you will see here, so okay, so this is your router, And once the packet will come to the router, this interface, suppose this is gigabit 0 interface, gigabit 0 1 or whatsoever, okay, ingress interface, okay. So what will happen? It will forward to the control plane where the CPU is used. So this is your CPU, okay. We can say this is the control plane, and here this is the router CPU, okay. This is the CPU, router CPU, okay. This is the router CPU. What will happen? CPU match the destination IP address with the entry in its routing table and then determine the exit interface and forward the packet. So all the packet, first packet will come, it will send this packet to the CPU, then CPU will determine the exiting interface, then it will send to the destination. One more packet will come again to the router will send to the CPU, and CPU will determine the exit interface and it will forward to the destination. Again, the third packet will come, again it will send to the CPU, and then it will determine the exit interface and forward the packet to the destination. Again, one more packet, it will come in. By this way, each and every packet will send to the CPU, and CPU will determine the exit interface and then forward the packet to the destination. Okay, so this process is very slow because each packet, even though it belongs to the same destination, it will because the CPU cycle processing cycle is required. It means every packet will go to the CPU, then the CPU will determine the exiting interface, then it will forward to the destination network. See, so each and every packet, it requires a CPU cycle. It means it is a time consuming. Even though the packet belong to the same destination, even though the packet belong to the same destination, it follow the same process. This is very slow process, okay? This is a very slow forwarding mechanism. This is a very slow the forwarding mechanism, okay? Packet forwarding mechanism. But if you will see now the fast switching, this is another older packet forwarding mechanism, which was successor of the process switching. It is almost the same, but they try to make it little bit fast. How they make it fast, I will explain you with this example. Suppose if the router is using a fast switching, and the fast switching use a cache to store the next hop information. It is using a cache. Okay, it is using a cache. So this is the CPU of this router. Suppose this is a router. Okay, so here this is router 1, suppose, and they are using, this router is using a fast switching. So what will happen when the packet arrive on the interface? What will happen? It will forward to the control plane, it will forward to the CPU, then the CPU will determine the exit interface. The first process is same, the first step is same, because here the CPU will search the match in the fast switching cache. If it is not there, then it will process the switch and forward the exiting interface. But then if this process is switched and forward to the exit into the flow information for the packet is then stored in the fast switching cache. So in the next step, it is going to be stored into the fast cache, because now this information, it is already processed. If the second packet belong to the same destination, now it is in the cache, because now in the fast switching, they have a cache. Now this information is stored into the cache. It will not send this packet to the CPU. It will directly check into the cache and forward to the exiting interface. Even the third packet also belong to the same destination. It will not forward to the CPU because this information is already in the forwarding cache, and sorry, it is already in the cache, then it will forward to the exiting interface. Okay, so in this way, the CPU cycle and the CPU intervention is rarely used. For the same destination, it is not used. Okay, because so now the next hop information is in the cache now, because the packet belong to the same destination, and now it will not send this packet to the CPU directly. It will forward to the exiting interface, because this packet 1, packet 2, packet 3, 4, and 5 belong to the same destination. Because of that one, this is a fast switching. This is a fast switching. Is it clear, all of you? Yes. Yes, please. Now clear? Okay. Now if you will see, sorry, what happened? Okay. Okay. Cisco CEF. CEF. Okay. In CEF, if you will see here, Cisco Express Forwarding. So Cisco Express Forwarding is the most recent and default Cisco iOS forwarding, Cisco iOS packet forwarding mechanism. This is the advanced one. Okay. And CEF built a forwarding information base fib. It is using a fib and change the trigger, such as when something change in the network topology, when the network has converged, the fib and adjacency table contain all the information that a router would have to consider when forwarding the packet. Now try to understand. So this is the CPU, okay? This is the CPU control plane, okay? And here, this is the routing table, okay? This is the router, suppose. This is the router, and what will happen? So even the first packet will not forward to the CPU, mean the control plane. So because all the information is it in the fib table and the adjacency table. Because in this way, if any packet will come, it will check into the fib table, forwarding information base or adjacency table, and then it will forward to the exiting interface. Through the it will forward to the destination through the exiting interface. So this is the most advanced and most recent packet forwarding mechanism. Okay. Now, if you will see here, first, if you will see process switching for each and every packet, even though it belongs to the same destination or the same stream of packet, it will go to the CPU. It means every packet requires a CPU intervention and CPU cycle. But in the fast switching, yes, it requires the CPU intervention for the first packet if the successor packet or the other packet belong to the same destination, then it will come because they are using a cache mechanism, and this cache is reused and without the CPU intervention, and it will forward directly to the destination network through this exiting interface. Okay, close the door. Don't come. Okay. So now Cisco Express Forwarding. Cisco Express Forwarding. Okay. Cisco Express Forwarding mechanism. What it is doing, it build up two table, fib table and adjacency table. It does not even require for the first packet for the CPU intervention. It will check the fib table and adjacency table and forward the packet based on the given information in the packet. Okay, and forward the packet. So these are the two different mechanism. Sorry, these are the three different mechanism to packet forwarding mechanism for the router. Now, if you will see here, so now let me slides here, block or unable to slideshow. Okay, so this one we already done it. Now I will show you one video in 10 minutes, and please try to complete that one in please open the packet tracer and complete this activity. Now just in 10 minutes, we already have I think 20 minutes left. So we will go for this activity. Okay. That video I will upload in the e-learning. Please watch the video, and or we can do it tomorrow, or we'll see. So here the topology, we will use this topology for our packet tracer activity, and this is just a review activity. Okay. Now these are the basic configurational command: how to change the host name, enable secret console, login synchronization. All these are the how to configure the SSH and how to configure the interfaces for IPv4 and IPv6. Okay, so these are the concepts. Okay. Now, so verification command, if you will see a common verification command, so if you need to verify, you can just simply write show IP interface brief. It will show you the complete detailed information about each and every interface. Okay. Show running config. If you will type this one, so it will show you the full running configuration, including interfaces, everything it will show you. Show interfaces, it will show you the interfaces. Show IP interface, all the interfaces. Show IP route and ping. So if you need to check with IPv6, just type IPv6, show IPv6 root, show IPv6 interface, show IPv6 interface brief. So just you need to type here show IPv6, then it will you can use the same command to verify the IPv6 configuration. Okay, so the filtration command, as I told you, so filtration command can be used to display the specific section of the output. Suppose if you are interested in interfaces, just you can type here the section and entire section, like SSH you are interested, just you can type SSH after the section command and it will show you only the SSH configuration. If you are going to include some command or exclude some of the configuration, you can include or exclude it and the begin or something like that. Okay, we will do inshallah in our practical how you can use these filtration commands. Some filtration command, or maybe most of the filtration command is working in the packet tracer, but I have a doubt with the section. I will check if it is working with the updated Cisco packet tracer. We can also use the section command just for verification purpose. Okay, packet this activity will do by tomorrow. Okay, so I already uploaded in the e-learning. Okay, because last, I think, yes, Thursday we have already done it. So now let me discuss here. So router sources. A routing table contains a list of route to know the network, because we have the prefix and the prefix length, and the source of this information is derived from the following: directly connected network, static route, and dynamic routing protocol. So the source of each route in the routing table is identified by the code. So as I told you, so I'll identify the identified addresses to router interfaces. If there's a C, it means directly connected network. See, this code is used to identify the directly connected network. If C is there, you can, if I ask you, check how many directly connected networks are in the routing table. So just go through this C, the code C, and check how many C's in your routing table. So based on the number of C's, you can identify this number of directly connected networks are present in the routing table. S stand for the static. As I already explained you, it identifies the static route created to reach the specific network. And 0 identify a dynamic. This is not a 0, sorry, this is O. O identify a dynamically learned network, but O identify for the OSPF routing protocol. And this static route is a candidate or the default route. If you configure a default route, it identify through this static. Okay, so these are the some of the codes. You can find it on the, see here, you can find it here. Suppose, as I explained you before, show IP route. So show IP route, if you will see here, now here we have C and L. So C stand for C identify the directly connected network. C identify the directly connected network. This C, this code, okay, this C code identify a directly connected network, and L identify the address assigned to a router interface. It means this interface we assign this IP 1.1. Okay, so it means on router 0, if we will read the routing table, it means we have how many C's are there? How many C's? Yes, please. How many C's are there on this router 0? How many C, code C, like mean how many C's are there? See here. So it means 2 C's. 2 C's mean it will identify the directly connected network. Okay, and L stand for it identify the addresses assigned to the router interface. Can you see this one? Yes, please. All of you, is it visible? Visible to all of you? Yes, please. Is it visible to all of you?
Yes, Mr.
Okay, so this identify the router interface IP address. Okay, and S stand for it identify the static route created to reach the specific network. Okay, so this S identify a static route created to reach a specific network. Okay, in this case, this is our destination network and it can reach through this interface. Okay, so now we can go to the, so what happened, where is the, okay, see here. Okay, now here, let me, okay, routing table principles. Okay, routing table principle, there are 3 routing table principles as described in the table. So these are the issues that are addressed by the proper configuration of dynamic routing protocol or the static route on all the router between the source and the destination. Now let's see what are those principle. Every route make its decision alone based on the information it has in its own routing table. Suppose router 1 can only forward the packet using its own routing table, and router 1 does not know what the routes are in the routing table of the router that is on the router 2. So it is very simple. Suppose every router have its own decision, whether it is going to forward the packet or whether it contain the route in its routing table or not. So if there is no route in the routing table, then simply it will check whether the default route is configured or not. If default route is not configured and the routing table does not contain the routing entry for that destination, okay, then simply it will discard. Okay, so the information in the routing table of one router does not necessarily match the routing table of the another router. Yes, this is 100% true. It will because just because the router 1 has a route in its routing table to the network in the internet via router 2. So that does not mean that the router 2 know about the same network. Maybe here, if you will see, I think, do we have? No. Okay, see here, this example. It doesn't mean this router have the same network on router 0 and router 0 does not have the same network as on the router 1. Suppose here on this router 1, it contains the default route to reach to the internet to the ISP, but this network does not contain here because it does not require it. Okay, so every router had its own routing table, and as I explained you, the routing table, because that does not mean that the router know about the same network, because each router will know the same network about the other router. So this should be clear enough. And suppose we have 2 routers, router 1, just let me read the another one. So what is the last here? Routing information about the part does not provide a return routing information. It means router 1 receive a packet with the destination IP address of PC1 and the source IP address of PC3. Destination IP address of PC1. Suppose this is the destination IP address of PC1. So which one? Router 1. See, router 1 receive a packet with the destination IP address of PC1 and the source IP address of PC3. Just because the router 1 knows to forward the packet out of this gigabit 00 interface does not necessarily mean that it know how to forward the packet originated from PC1 back to the remote network of the PC3. It means it is not necessarily you have configured the both network, because on the both routers, suppose here you configure 1.0 for this network, but you did not configure this network on router 1. It means it will reach to the destination, but it will not able to send the reply back to the source. Okay, so it is something like that. Okay, so it means router 1 receive the packet with the destination IP address PC1 and source IP address of PC3. This is the source address, but router 1 know to forward the packet out to gigabit 00 interface, but does not necessarily mean it know how to forward the packet originated from PC1 back to the remote network of PC3. Okay, so the number of identify the following information: routing table entries. Routing table entries, if you will see here in this table here, destination network, mean prefix and the prefix length, administrative distance, matrix, next hop, route timestamp, exit interface. So if you will see this identify how the route was learned. root source. Root source mean what is the source? How it learn? It learn through the static routing. It learn through the destination. Sorry, the dynamic routing and destination network. And this identify the address of the remote network. And administrative distance, this identify the trustworthiness of the root source. Lower value indicate the preferable root source. See here. So longest match, leave it. Now we know about the longest match prefix notation, but the second, as I told you, the best. See now, suppose we have this network. Okay, in this network we configure a RIP, routing information protocol, RIP. Okay, this is a dynamic routing protocol. And what will happen? The RIP administrative distance is, what is the administrative distance of the RIP is? See here. Now I will show you the administrative distance of the RIP. See, administrative distance of the RIP identify the trustworthiness of the root. Okay, if you will see here the RIP, RIP administrative distance. Okay, administrative distance is 120. Okay, so RIP 120, EIGRP. We can see RIP, EIGRP, and OSPF. RIP, EIGRP, and OSPF. Okay, so we can see the administrative distance. Now, if you will see now, see here. What happened? See, now, if you will see here, so the RIP administrative distance is it is okay. How to configure administrative distance? Okay, this is EIGRP, OSPF. Okay, so RIP, EIGRP, OSPF administrative distance. Okay, so we can check. What is this one? Okay, now if you will see here the static routing, the AD value is 1. And if you will see here, RIP, the administrative distance value is 120. OSPF administrative distance value is 110. And EIGRP, if you will see here, the EIGRP administrative distance is 90. So it is mentioned that the lower value indicate the preferable root source. Lower value indicate the preferable root source. If you configure EIGRP, OSPF, and the RIP for the same network, okay, so which one will be selected? Your EIGRP protocol will be selected in order to calculate the best path, because the administrative distance of EIGRP is less. EIGRP is less. Okay, just try to understand this one, because the lower value indicate the preferable route, and because the administrative distance, what is the administrative distance? The trustworthiness of the route. Okay, so it means the EIGRP, sorry, EIGRP will be used to calculate the best path. Okay, so come to the slide here. Matrix. The second thing, to identify the value assigned to reach the remote network, lower value indicate the preferable route. We will inshallah explain you in detail. So what are the metrics used for to calculate the best path? Okay, to calculate the best path, we will use some matrix value. Mean the bandwidth and so many things are there. Mean for what is the matrix value for the RIP? The hop count is the matrix value. Okay, hop count. In this one, suppose if how many hops are there from source to destination? So mean one router is away. If we are using 3 router from source to destination, it means what is the matrix value? 2 routers hop away. Mean 2 routers hop value will be this one for the RIP. Okay, we will discuss once we will discuss the matrix calculation. Okay, so for the time being, the matrix value, what is the matrix value? Matrix value identify the value assigned to reach the remote network. Okay, and if you will see now, next hop. So this identify the IP address of the next router to which the packet would be forwarded. So this is the next hop. What is the next hop address from this? So next hop will be, in this case, what is the next hop? This router is the next hop. It means it will identify the IP address of the next router, next hop value. Okay, so this is the routing table entries. In the routing table, we have the router source address, destination network, administrative distance, matrix, next hop address. So these are the things are in our routing table, next hop. So this is the next hop address, and we can also have the exiting interface. It means if we did not identify the next hop IP address, suppose next hop mean this router IP here, then we can identify the exit interface. It means the egress interface is used to use for the outgoing packet to reach the final destination. In this case, we use the egress interface. Egress means this interface to reach to this destination. Okay, to reach to this destination. So this is the routing table entries. Okay, this is the routing table entries. If you will see here, the routing table entries, just to show IP route. See here. So show IP route, or we can also write these command like as I explained you before, some of the commands like show IP interface brief, show IP. Just 1 minute, I will explain you. Show IP route, show IP interface brief. You can also type show IP interface brief if you will see here. So these are the two interfaces. See here. So you can type show IP interface brief, and this is the one. Okay. So here we don't have and show IP route. Show IP route. See here. So this is the IP route, and I think in couple of other slides I will show you the static route entries and the administrative distance and all these things. Okay, so now any question regarding to these routing table entries and directly connected network? We already discussed static routing. We already discussed about in detail what is the static routing, and these are the command we already discussed. Okay, so and yes, we are in dynamic routing protocol. Okay, so this one we will discuss tomorrow. So what is the static routing dynamic? Again, we will discuss, no problem. Okay, so now today what we have discussed, we discuss about the routing concept. Okay, and in the routing concept, we discuss about the path determination, packet forwarding mechanism, and basic router configuration review. We have seen, but we will do the practical by tomorrow. And please, I already uploaded the video for this practical in the